Okay, then I will start. I will try to speak slow and make some pauses so that it's easier to make some translation. Okay. Yes, my name is Артурс Рієкстінс. I'm a project manager at Latvian State Roads. As well, I'm a PhD student at Riga Technical University. So today I will share our experience with the chrome rubber in asphalt. We did a literature review and comprehensive laboratory testing.
I'm sorry, Arthur, can you share the presentation? Because we don't see it.
Sorry. Yes.
And
can you hear?
Perfect,
can you
perfect.
Okay, that's good. So, shortly about the content of the presentation. I will explain why we did this research, what are the wet and dry process, aim and objectives of the research, what kind of laboratory works we did, some results, conclusions, and if there will be time, then I will answer to the questions. Okay, in Latvia, we have more than 100,000 tons of old tires in stockpiles and landfills. And these numbers keep rising each year. It is possible to use chrome rubber in for children playgrounds and for artificial football fields, but the capacity isn't enough. So another way where to use chrome rubber from old tires is in asphalt. So how to use an old tire rubber in asphalt? Wet process is the most widely used way. It means that bitumen is modified by rubber up to 25% by the weight of the binder. The main advantage is that this technology could improve fatigue and low temperature properties. But because of increased viscosity, a higher mixing temperature is necessary. And therefore, it is suggested to use together with bar mix technologies.
Технологіями.
Method,
Іншим методом, під час якого описується цей процес,
rubber content is 1 to 3% by the weight of the mineral material. This is the main difference if we compare to the first one. Asphalt producer doesn't need an extra equipment. That's one advantage. But the main problem is that good laboratory mixture design is critical. The main problem is that asphalt rubber can swell in contact with bitumen. So, and that could result in a higher air void content and reduced mechanical performance. And after literature review, it can be concluded that this method doesn't improve properties of the mixture. And in the lower right corner, you can see how this rubber particle looks inside of the asphalt. I hope you can see. So the aim of the research was to analyze the influence of crumb rubber on the physical and mechanical properties of dense graded asphalt. Objectives were collection and testing of raw materials, bitumen modification, crumb rubber, and design of dense graded asphalt concrete according to our specifications. Testing of physical and mechanical properties of these mixes. So flowchart of the research experimental part. So we compared 4 mixtures. The mixture 5070 and PMB are as references. The name of these mixtures explains the main idea about it. So for example, 5070 means that paving grade bitumen 5070 was used for this mixture, and the same with the PMB, just polymer modified bitumen was used. VP means it's a wet process, and DP it's a dry process. And for wet process, a 5070 bitumen was used, which was modified, and war mix additive Evotherm was used for the purpose to decrease the temperature of the mixture. And for DP, 5070 bitumen was used, and 3% of rubber from the mass of aggregate were added. That's a lot, so we'll see the results. And to make sure that the mixtures are good, conventional tests were done. After optimal mixtures were obtained, performance tests were done. All mixtures were tested by the wheel tracking test. The x-axis represents a number of crossings, and the y-axis rot depth. As you can see, then the mixture PMB showed the best result, followed by 5070. Slightly weaker result showed mixture VP, but still it's a good result. The worst result was obtained by mixture DP, and it is the only mixture which doesn't meet the requirement. For this kind of mixtures, we have 5.6 millimeters. So as you can see, this is the only one who doesn't meet the requirements. On the right, you can see the TS-RST test results. For this test, basically is the purpose is to see how good mixture perform under low temperatures. The x-axis represents a temperature and tendency, how it decreases, and y-axis stress, which increases with decreasing temperature. As you can see, very impressive result was obtained by VP mixture, followed by PMB, but the worst one was for a DP. And the same as in the wheel tracking test, this mixture wouldn't meet requirements. From 2021, we plan to test for quality control asphalt samples, and the value for varying courses would be minus 22.5 degrees. So here you can see results from a 4-point bending test. Each point is one sample, and the x-axis represents relative deformation, and the y-axis the number of cycles, how much each of the samples could withstand till stiffness is decreased by 50%. And very similar to TS-RST results, also in this test, VP mixture showed very good results. And the reason for that is because higher viscosity of binder allows to use higher binder content. And for VP mixture, it was 6.5%. And that leads to less stiff mixture, which can better absorb deformations. Second best result was obtained by PMB. It's followed by DP and 5070. Yes, on the right you can see that for VP, initial stiffness is the lowest. Main conclusions based on the results of the study. So Kronberger modified bitumen improves low temperature properties and fatigue resistance of asphalt. Because of increased viscosity, higher temperature is necessary, and it results in more fumes at mixing, laying, and compaction processes. Therefore, it is suggested to use warm mix technologies to decrease temperature and improve workability. And it was successful in our study. In our research, a dry process showed the worst results in almost all mechanical tests. But we believe that it is possible to improve properties of this mixture, because very high rubber content was used in this case. But overall, the use of wet process is more promising than the dry process. Based on this research design for road with dimensions, the length 1 kilometer, with width 7 meters and thickness 0.0 meters, we would need for wet process 11 tons and for dry process 23 tons. And this is not all, but for the winter we are planning to try chrome rubber in stone mastic asphalt. And as you can read it in literature, in scientific publications, then there is some promising, there's some good successful stories in this type of, if rubber is used in this type of asphalt. And maybe we will do some research together with the university to make some guidelines for industry how to get the best out of this, especially with the modification process. And also there is a high chance that one of our constructors, in cooperation with the university, next year will build some experimental sections. So we will see how this type of asphalt performs under real conditions. And that's it for me. That's all for me. And if you have any questions, then you can ask or just write me to my email if you want to know something with more details. Yeah, that's it.